Okay, so last week was test week. Did we all get that done, dealt with?
At the bottom is, I was looking this morning, it said like, exam 1, is that the same as test 1?
Yeah.
Okay.
Yeah. Different people use different language on that. I've always been a tester, so yeah. Okay, but we all took a stab at that, got it done. Okay. If not, you probably want to do that soon. You don't want to put that off a long time. So last week, we didn't do a lot last week since it was test week, but we did start 4.1, which was all of this nonsense from before. We're going to kind of go over the big equation from that because we're going to use it again in a slightly different way. Part of it, it's all related. So that's our correlation. Another thing I wanted to point out, that is us. Sorry, I have too many canvases open. If you go to modules and go to the in-class notes videos spring 2025 link, you'll notice I've included a new spreadsheet here. Can you see my little mouse? This guy? That's going to open to this Google spreadsheet I keep using. You should have read access on that. So when I do my little formulas in here, where did we have? Had some formulas here? No, we didn't. There we go. Last week when we made formulas, or we had our data and we didn't want to sit there and multiply and add and If you scroll into these cells, it'll tell you what the formula is. You can see way up here, it's really small. They'll tell you how to make the formula. And then down here, it's going to tell you what you did there too. So if you want to do some of this on the Google Sheet, you can, and you can please steal my formulas. That's why I've posted them. I think you should be able to see all that. You shouldn't be able to change it, but it's read access, so it should be good. If not, let me know. Also, I thought it might be helpful. So when we're doing stuff, you can just pull up the data directly rather than me printing off a bunch of stuff. Can I zoom in? Wait. Wow, where'd you? Yeah. So you can pull up the data directly and play with it that way. It makes it a little easier too. So we will do some of that today. Brain, here we go. Okay, so last time we talked about correlation coefficient, which is our R value. This measures how well our data fits a line. So sometimes we'll get through plot some data. We're going to use this in a sec. And our data looks pretty linear. You're like, okay, a line is probably a good fit for that data. But that is not always the case. Sometimes we have something where you've got some outliers here. Let's throw them down here. Look at this. You're just like, well, some of them kind of line up. But we can find a lot of different lines that connect a bunch of points. So maybe a line isn't a good fit for this data. What our correlation coefficient does is tell us like a percentage of how well our line fits the data. So our R value is always between -1 and +1. And if you just look at the absolute value, so ignore the sign, it kind of tells you the percent that the line fits the data. If you think about it as 0.2, that means your data is about 20% linear-ish. Kind of think about it like that. So you want to be close to positive or -1. Okay. Last time, we dealt with this massive equation, and we're going to do that again. But I'm going to do a lot of it in my Google Sheet. So if you have access, everybody has a computer in front of them now. If you want to open that, it might help. You'll probably see me working real time on there, and that's fine too. So we're going to find the R value for this data. I pulled it off of the PowerPoints. I'm not sure what it means. It just was the data I had. So I'm gonna come here to my Google Sheet. That's not my data. All right, so chapter 4 data. I'm gonna need to write on this in a sec. I'm gonna label my columns. This is my x times y, x squared, y, whoops, y. Those are all of the columns I'm going to need. So my first one, I'm gonna say equals, yep, x times y, beautiful. Oh, you did not do that. I wanted you to do. Haha, now it did. And they're nice, they autofill for us. So they're gonna multiply all of them. So now each of these boxes took your x times your y, calculated it, equals our x value times our x value. Autofill, yes, thank you. And this one equals my y value times my y value. And yes, I would love it if you autofilled for me. So that took a lot of the grunt work away. Like, we can do that easy, just plug them in. The last thing I want to do is make a summation. So equals sum, parentheses, highlight what I need, close my parentheses, and enter. I'm gonna bold this so I don't lose it. Maybe. There we go. I Control C, Control V. It'll copy the formula and do it for each individual cell. So now I'm going to take a moment and write these summations down because I did not. I get the sum of x is 49. Sum of y is 1120.7. Sum of my xy is 7756.1. Sum of my x squareds is 455. Y squares are 179,494.95. And I have 8 data values, so my n is 8. I'm going to rewrite those in a sec, but yeah. Okay, I did bring my calculator today. Yay, go me. So based on our spreadsheet, we have the sum of our x's is 49. The sum of our y's was 1120.7. Sum of xy, we multiply our columns, 7756.1. Squares. I'm going to move this over actually, 455. And my y squares, 179,494.95. And my data values are 8 of them. We're going to use all of these numbers again for the next piece for 4.2. So we're good. All right. Someone forget it. Okay, so I'm using that monster equation above us. My R value equals the sum of xy, so 7756.1 minus 1 over n, which is 8, times my sum of x, sum of y. So 49,120.7 all over
Okay, the sum of x squared is our first one there, 455 minus 1/8 times my sum of x, 49 squared. I find that the hardest part of this formula is knowing which one sum of x and sum of x squared are. So I've highlighted them, which I hope helps a little bit. All right, then we do the y's. Same thing. 179494.95 minus 1/8 times 120.7 squared. Okay. Now I get my calculator out and calculate. I'm just gonna do this. I'm gonna do it in kind of 3 big pieces, and then I'll talk about it after that, but I don't just want to talk numbers for a minute. So I do this in 3 pieces because I know that I'm gonna need this number again and this number again. You don't know that yet, but you will when we're done today. We're gonna need those numbers again. So rather than calculate it twice, I'm gonna do this, and then I'm gonna do the next part. Just FYI of what's coming. All right, the last thing, I'm actually going to calculate it now. 891.13 divided by square root 154.875 times 2 times that guy there. Ooh, really? Yikes. So I got 0.478. Let me double check. Yeah, and that's that number. Okay, oh yeah, that's that number again. Yeah, okay. So our correlation coefficient is really lousy. We have a 0.48 or 0.478. This tells me our data is probably not very linear. So if I were to graph it, it's going to be all over the place. So data is not linear, or our data does not fit a line very well, however you want to put that. It's just not the right model for this data. Maybe there is another model, or maybe it's just not. Like there's maybe not a model. That happens sometimes too. Probably would have been good to graph it and look at it, but that's okay. This is good enough for now. Okay, that is the stuff we did last time, just to kind of bring that back. We'll bring this up again as we go. So the next piece is our least squares regression line. And so now we've calculated how well our data will fit a line. Now we're actually going to find that line. So we use statistics. Find the line of best fit. Our goal is to get as many data values either on the line or really close, or at least minimize the distance between the ones that don't fit the line. So let's say we graph our line. I fit my maximum and minimum data values on there with respect to X. And then we have some data values that are above and below the line. What we can do I have a gray one on here? Hopefully. We can measure that distance, how far it is away from the line. And we're going to manipulate the data, not really manipulate, but like massage the data so we can calculate how much that distance is and minimize it. That's really what we're doing. It's called the y-error. Or it's also called the residual. That's how much is our data value off of our line. We can also compare it to the mean, where it should be, and do things. So y hat equals predicted y. So we're going to take our predicted values minus our actual values and do stuff to it. That's kind of how we think about it. We have a more exact equation. If you take another stats course in a different book, this might be M and B instead of B1 and B0. This is the first time I've seen B1 and B0 in a book. Oh, that should be plus, not minus. But it all shakes out to the same thing. Okay. The PowerPoint tells us that B1 equals R times standard deviation of Y, standard deviation of X. But that requires us to calculate all of that, and that's not always really feasible or helpful. So what I did is I rewrote this in more helpful terms. What I think was more helpful terms. Or sum of X, Y minus 1 over N, sum of X, sum of Y, all over sum of X squared minus 1 over N, sum of X, quantity squared. That equation should look familiar because the top is exactly the same as the R equation, and the bottom is what's underneath that first square root in the R equation. And this is why I have a step, calculate that middle step, because I know these two numbers are going to come back at us. So it's related. It's not exactly the same, but more or less. I would use this version of the equation, not the other one. Because if we've calculated our R, we already have those two numbers, we just plug them in and it's one extra step. It's an easy step at that. So that's our B1. Our B sub 0 is the sum of Y over N minus our B1 value times the sum of X over N. So we're the mean of Y of X. So you'll know, oh, that looks really bad. There we go. You'll notice our B sub 0 equation uses B sub 1. So we have to calculate 1 before we can calculate the 0. Order matters in this case. Okay. Oh, I hope I typed that in there. If not, we'll figure it out. I'm going to try to keep these on the screen. Do that by scooting you over here. Okay. My X and my Y. I have 1, 3, 3, 6, 7, 18, 13, 9, 6, 4. Okay. We're going to calculate all of the bits. So we're going to find our R value, use that to find our B1 and B0. Let me see if I can rearrange this a little bit more to fit everything in here. Best thing about a tablet is you can move things as you want to write them. Okay. So I'm going to go to my Excel sheet and throw these in there, or my Google sheet, whatever, it's the same thing, to get my summations so I don't have to calculate those. I did not write down this data, so that's okay. I have my X and my Y. I'm gonna bold this. 1, 3, 3, 6, 7, and 18, 13, 9, 6, 4. Get my columns first. X, Y, X squared, Y squared. Yep, that's okay. Equals X times X. Yes, autofill. Equals. Yes, autofill. And I have to fix this one. I'm going to scribble these down on my sheet and then move them over there. Okay, there we go. Okay, so find your R, find your B sub 1, and find your B sub 0. You have all the tools to be able to do this, so go give it a shot. I'm going to pause the video and then we'll meet back. Okay, I'm going to give us the equations we need because there's a couple more things we have to do with this. So actually, I haven't calculated. Well, I have the final answer, but I don't have the in between calculations. Alrighty, so the R value. I actually don't really care about the R value in this case. No, I did not get an R value. Go me. Okay. Yeah, try it. So I'm gonna get my B1 because we have to do that first. Bring this down a touch. So that equation says sum of xy, which is my 148 minus 1/5, sum of x, sum of y, 20 times 50. So ideally, if we did the correlation coefficient first, we'd already have all of this, but that's okay. And I get 104 minus 1/5 times 20 squared. There was a question of the sigma symbol, the sum. Once that just tells us what to do. So it's an operator, kind of like adding or subtracting. It says, hey, do this thing. It's a common symbol in the math world to say, hey, add up whatever comes next. So once we have our sums, we don't put them in the equation anymore. We've already done what it told us to do. That is a really confusing thing, but there's not really a better way to write it unless you want to write a whole bunch of X's. And nobody got time for that. So, big deal. Alrighty, let me plug things in my calculator. 148 minus 20 times 50 over 5. I got negative 52 over minus over 5. Yep. 24. So it looks like it's going to be 2 and a bit, which is what I have. Negative 52 over 24. We probably want a decimal for these. Negative 2.167. I'm going to go out 3 decimals just because. So that's our B1. Once we have that, we can find our B0. So our B sub 0 equals the sum of y over n minus our B1. This is a tricky piece right here, and I'll talk about why. Times my sum of x, which was 20 over 5. Be cautious. This sign is a negative. If our B1 is also a negative, that's a double negative, which means it's a positive. So be careful of that because this is going to end up being addition. So 10 plus 2.167 times 20 over 5, which is 4. Perfect. I get 18.668. Excuse me. On homework, go out more decimals because what the PowerPoint's found and what I found are slightly different, but it's fine for our purposes for now. Okay, so that means our line is negative 2 point, which should be y hat, 167 times our x value plus 18.668. So if I were to graph my data and graph my line, this line should go through or be close to several of our data values. Now, our whole goal in creating this is to make predictions. So we want this and we want our predictions to be as good as possible. So this says, okay, if we have any X value, we can predict what we think our Y value is going to be. And the better our R value, the better our prediction. I don't remember what our R value is for this one. I don't know that I calculated it. So ideally, this is a great fit and most of our data is exactly the same, but we don't live in the ideal world. That's not always going to be the case. So we have to calculate the residuals. And we only do this for this section, maybe the next section. What we do is we take the sum of our actual Y value minus our predicted Y value and square. So take your actual minus your predicted, square them, and then add them up. So the fun part is we get to figure out what our predicted are. I'm going to use my sheet for this. So our Y values were 18, 13, 9, 6, and 4. My Y hat values, I'm going to find these on my sheet. So I'm going to use my sheet to circumvent some work here. Okay. So this is going to equal, actually, equals our equation, which was negative 2.1676 times my X value plus 18.67. Wait, I used a different. What was our 667? What was our B1 value? B0 value? 668. So if you can see in this top little thing, what I did was wrote our equation times our Y, and this is going to calculate the Y hat for us. Hey, I don't need this value though. Can I hide? I can hide. Well, that did work. Okay. I hid my cells. I'll unhide them in a sec. So now we can look at our predicted Ys versus our actual Ys. Most of our data values are pretty close. So my first predicted Y was 16.5 and my actual was 18, etc. We can kind of compare them all down the list. Now, unhide. This is going to be Y minus Y hat squared. So equals parentheses Y minus my Y hat value. This is going to work like I want it to. Yeah, I think it did. Yeah. So my column here took all my Y values minus my Y hats and squared them. That doesn't seem right. Does. So it tells me my residual here is approximately 13.3. So we're off a little bit, which we kind of expected. Gee. It. We calculated that from the other sheet. Subtracted and added. Okay, I know we have this on the other sheet, but we're gonna kind of bring it back together. So using our equation, we're gonna predict what our y value should be when our x is 6. So I'm gonna plug that into our equation. We say, stop it, y hat equals -2.167 times 6 plus 18.668. -2.167 times 6 plus 18.668. And we're guessing that our y value is 5.666. One number there. So if we go back and look at our data, our actual y value is 6, and our predicted y value is 5.6. That's not terrible. We're pretty close. The more data values we have, the better our predictions, clearly. We had 5 data values, which is tiny for a data set, but we get an idea. Okay. Does that more or less make sense? Do you want to try one more y equation example, like to find the equation? Okay, we're gonna, that's how we're gonna end. We're gonna throw one last example in there. Let's do the club data that we had from before, because I have a lot of that already. So if you're in the sheet, there is this data written out. Somebody asked for editing access and I just gave it, it's fine. Okay. I'm just gonna write this out even though we have it. 100, 2, 103, 101, 105, 100, 99, and then, no, we don't fly away. Thank you. 257, 264, 274, 266, 277, 263, and 258. Okay. I'm going to pause the video here, get my summations, but we're going to find all of the things, which is really not as much work as it seems, a little bit, but so the things we're going to need: my sum of x, my sum of y, and sum of xy, sum of x squared, sum of y squared, And my N, which I can get right away, 1, 2, 3, 4, 5, 6, 7. I'll pause the video because that's boring. Okay, I calculated all the things, so we had it, stupid screen. We had our summations up there, which I got from my spreadsheet again. It's not, it really just wants to be a jerk. Nope, wrong thing. Nope, wrong thing. Okay, it's gonna do what it does. So through all of my numbers in there, you'll notice that I used my R calculations here to help with my B calculations. I did not recalculate any of that. I just kept it in my calculator and threw it in there. And we get a line of best fit. So since our R value is 9.3, that means our line is really good. It should be a good predictor of our data. So if we were to throw any of our data values up here in there, it should give us a pretty accurate outcome. So we could test that. And that's kind of what we're doing with this is, can we test it? Can we make some good guesses? Can we extrapolate from our data? Okay, that's all I have with this stuff. So I'm gonna stop the video altogether. We're gonna finish chapter 4 on Wednesday. So let me know if you need anything.